Hello guys, my name is Ben. Welcome to my C programming language tutorial. So today I want us to do something fun, and this is what actually make you to be able to write real world application in C programming language. So what are we going to talk about today, guys? So we're going to talk about something called processes. Okay, so what are processes? Processes are the programs you write, okay, but there is a little bit different here, which is what people don't get right. In C programming language, you write programs that can duplicate itself. One will act as the parent process and the other will act as a child process. There can be more than 1,000 processes running. If you change to your /proc directory, you're going to see a lot of processes that are running. Most of them are like, okay, so they normally have parent process and a child process. So that is what we're going to do today, practical aspect of it, whereby we are going to write a program, and our program will be able to create two processes that will be running at the same time simultaneously. One will be the parent process and the other will be the child process. Both of them are going to be doing different things at the same time, or maybe difference in seconds. Okay, so without further wasting of time, let's dive straight into this video. I have two terminals, or let's say three terminals. This one here, you are saying moving up and down, is the record himself. Then this will be where we are writing our code, and this it will be where we are going to be shaking and seeing processes that are running. All right, so let's start writing this code. So I'll use mkdir to make a directory, and I will call this p uppercase r_pen. So I just like figure that name will be nice. Okay, _pen, press enter. ls, this is a clean empty directory. I will use touch to create a file, and I will call this file pen_process.c. Alright, so I press enter. So ls, so you can see pen_process is the C programming language. Whenever you're writing any program, it must have any program in any language, it will have an extension which will end with dot whatever. So in C language it ends with .c. Maybe in Java it will end with .java. In JavaScript I think that is .js. In Python, which I know very well, is .py. PHP, I think that is about .php. Yeah. All right. So I love using a Vim editor, which is a CLI command line editor, not like the GUI you guys use like VS Code, no, or Sublime Text. No, this is the Vim editor. I love Vim because it's a command line tool, and it has this beautiful keyboard key shot that makes your work faster, clean, and makes you look like a professional. So we use Vim, so pen_process I. So we start writing our code. So first of all, I'll give a comment here. I will say author. Okay, author here is me. Okay, my name is what? Pen. Alright, so I will just close that comment. Then after that, I will give another comment to say this is the C, okay, standard functions. Okay, so I will just close that. So under C standard functions, we're going to be including some other files to access those functions, like stdio.h. okay, and I will do my best to comment this code. So when we use stdio.h, we have access to functions like printf. Okay, we have access to something like fprintf. Okay, and let me just put those two for now. We need to access the string header file that give us access to the string error function. So I'll just pass in the string.h header file. Okay, header file to access the functions like string cpy. Okay, or this one is one I'm going to be using in this program for error checking. All right, so there are pretty many of those functions. Okay, a header file can have more than 50, 60, 17 functions in it. You can browse that through your Linux. It's by default in the Linux. So their directory is called /usr/include, where you see a lot of them. You can shake through them and you see a lot of functions. And there's also some Linux command line that you can punch in, and it will give you those for you. If you want me to do videos on that, just put it on the comment section of this video and I'm gonna do it. Okay, so we need to also include more header files. Okay, like the error number .h. So this allows us to use a constant of error number. Okay, this is not a function, it's just a constant. Okay, I think these are the pretty 3 header files for now. If there's more, we'll come back and include it. So I'm also going to give a comment here that says, because we are going to be using or playing more with system calls functions. Alright, so make sure you pay attention as I'm coding. You are coding with me as well if you are watching the video. Alright, so it should be asterisk /. So what are the system call header files we're going to be including? I'm going to include first file ctnl.h. so what this allows us is to, which I don't know if we're going to be using the open system call and the close system call. There are other pretty ones, but I'll just be like giving two. Alright, so I'm also going to include the system call header file called unistd.h. alright, and this gives us access to stuff like read system call and write should be spelled RITE, write system call. Alright, so we also need to include one more, or two more though. We need to like pass in the types.h, which allow us to use types. We also need to include the sys/wait, which allows us to use the wait system call. Alright, I think these are what we need for now. If there's need for more, we'll come back. I will do my best to comment every line I'm coding here so that you guys understand. So I will just do a quick comment here. I will say CPU start executing from the main function. So that's where the CPU start executing from. So I have to create my main here. So I would like to pass in argument of counts, not actually needed, but I just love to do this. Should in case if I will be needing it, there will be no need to declare it anymore. Environment process and open curly brace, and since we are returning an int, we return 0 semicolon. Why we did it is because in the main function here we return int, so therefore the function need to return it integer value. So 0 here indicates program successfully. So it means indicates process, or will you say return exit, or let's say return success. So that's what that means. So here now, so this is where in the middle here my cursor is blinking, is wherever for our code is gonna live. So I don't want this video to be that long, so I'm gonna be pretty fast typing. Not that I'm very fast in typing though. So PID_t is a type created with type dev keyword. So if you know C, you should know the type dev keyword that was used to create this type. So if you want to see that, you can just check the fork system call. It's going to show you that. And we're going to be using the fork system call here to create two processes. So I will say what this does is to, I'll just comment this fork system call. What it does is to create two processes with same names, comma, one, let's say first. Yeah, I think first would be the right word there. First is parent, and second is child. Alright, so when these processes are created by fork, we have two processes. One will be the parent, the other will be the child. So that is what this function here will do. It's going to create like this. Now two processes has been created already. So now we play with those two processes. So we use if statement to say PID, we are checking for error false if less than 0. Okay, then we enter here. So the way we check for errors in when you are using the fork system call for creating parent and child process is that you check for the error false before checking for the child, and the parent will live in the S. But in other system calls, you don't do it this way. You first of all check for errors. Once you have do your system call definition, then the next thing is to check for errors. Alright, so that's what we're operating the window. So we check for errors here. So I will just give you a quick comment here. I will say error checking. Alright, so that's it. Hope you guys are following. So if there is error here, so we like to get that error printed to the screen so that we know what kind of error we are getting and the error number associated to that error. Okay, we'll type stderr, which is the value to constant that sent to the screen monitor of the standard error. So error supposed to say errno column %d. So we want to get the error number. Then after that, we love to get a string that we elaborate more on what the error is all about. We pass in new line, we close that comma, error number, comma, and we pass the string error system standard library function. Inside it, we pass the error number as an argument into its parameter. And once we are done with that, put our semicolon. Then the last thing here is that I will be using the system call, not the standard library exit. I will be using the system call. So here we pass in the PID. If we're to be standard library, I'm just going to pass in failure or success or 1 or -1 for the error. But since we're creating a process here, it's better we use system call. Alright, so I will just tell you what this does. It terminates the processes. Okay, that's what it does. So it terminates using the sync termination. So once that is done, we close that. So but if there is no error here encounter, then we face the else if to check for another condition, doing PID this time. If equal to 0, then we are in the child process. The child process will never execute if you do not force it to do so. So I will just comment this. I will say child process memory space, and that is it. So we start now doing this. So I would just like to sleep for 15 seconds, so which I see pretty good. But if 50 seconds is not that pretty, we can say 20. Okay, let's say 20 seconds. So you know what 20 seconds is now. 60 seconds is equals to how many seconds? When we have 20 seconds, yeah, you just not have to count it yourself. So here we do the printf. So what we'll be printing here, we'll just say child process running \n. Okay, yeah, child process running. I'll just do another \n. Let me just give a single space there. Alright, so the next one is we can put a printf again. So under this printf now we can say should be on quotes, no, child process, okay, ID. So here now I want to get the child process ID in child memory space. So the way we do that is that we put this and we put get PID function to get that. And once that is done for us, I will just put a comment here and I will say getting child process ID in child memory space. All right. So another thing we can do here, even though we are in the shared memory space, we can also jump to the parent memory space and get the parent ID and come back to the shared and continue execution. So we do that with print. Just trying to make this program a little bit. So I will say shared process. Okay, now we see getting parent process ID. All right, column apple %d. So we are in the shared process, but getting the parent process ID. So isn't that wonderful? So put this, and I will just type to get the parent process ID. I'll type get PPID. So what that PP stands for is get parent process identity, and I will just put a quick comment here. I will say go to parent memory, okay, memory space, and get its ID. All right, as there is / and that is it. So go to parent memory space and get its ID. So once we are done with that, then I would just like to print new line here, 2 new line. All right, and that is it. Okay, that is it. So I would have loved to kill it, but because of want to do retest, so I won't kill this. So I will just close this. So the next one here is else. So this else now is where the parents will not live. So I will do a comment here and I will say parent process memory space. So here now I also like to sleep for that same 20. Let the child don't be up to 20 so that the child can execute. Okay, let it be 20 though, so that it can delay us to see the process. All right, so so we can now print F. If the delay is too much, I will just come back and reduce it. So I will say child. I will say sorry, parent process running. So even my child here is kind of like, okay, parent process running. I think that's okay. So I'll close that. So the next thing here is to print the parent ID itself. So I will say parent process ID double %d \n. Then here is where we'll now pass the get PID again. Okay, and I will explain what this means after I just put a comment for it. So I will say here getting parent process ID in parent memory space. All right, so what this is doing here is that once the program starts, it check for the error. Once it's done with the error, it doesn't execute this because the PID is never equals to 0. Once this is initialized, the process is created. The kernel itself is what gives us a process ID, so it's never equals to 0. For that reason, the else will be what to execute. So when the else executes, you get the parent process ID. Okay, so that is it. So this is what we run first. All right, so let me just now be in this parent process memory space and get the child and jump to the child memory space and get the child ID. So I will say parent process. So I'll put column on our type getting child process ID %d, all right, \n double quotes. Then here now what will I put here is PID, which is getting the child PID. So this will be an increment of 1. So if I comment this, I will say go to child memory space and get its ID okay, and that is also it. So once we are done here, right, we can just end this for now, and I think that is it. But before we end it, we need to do something. Remember I told you that the child will never execute except the parent allow the CPU to jump to the child process ID and execute the child. So what we're going to do here is to call the wait system call and pass in null. So the null is what allows us, so I will comment here, allows us to jump to the child process. So what I'm going to do here is, okay, I'm going to say wait, the comment here should be wait for child process to finished and return back to parents. All right, and that is it. So now we close this, and that is it, everything about this. So if there's any error here, but let me explain the code real quick. Okay, first of all, we create a process ID here. So this is the code for creating, this is the code for creating the process ID. So this duplicate, you can see with the comment here, create two process with the same name. First is parent and second is child. So we start our checking. The first one code here down to here is checking for error. If we find any error, the program will exit. That means the process will terminate. The program will not do anything again. That means none of this code here will run. If this first line here is truth. But if this first line is false, then we are given chance to do another check. So the first check is that we are doing for child. So this is the child process. You see child process memory space. We allow the program to sleep for 20 seconds. But what happened that this child process will never execute because the PID set by this is never 0. So for that reason, this will be skipped also, and we will now land ourselves in the else, which is the parent process. So the parent process will execute in the memory, but will not be printed out. So because there is a wait system call here. So this wait now, we say wait for child process to finish and return back. So this wait, what this wait is do is that once you encounter this wait, is going to jump to the first place to execute the child. So the child process will now run first. When the child process finish running everything inside it, will now jump back to the parent process and start executing from here to the end. Okay, so let's see if everything we just explained is true. So you can move up so that you can see the whole code as I'm going small. Okay, you can see the whole code here. So if there's any error here, we'll just come back and fix it. All right, you can pause the video as I'm scrolling up to see through all this. Okay, so escape shift :WQ, press enter. So ls, we have our source code. So we compile with gcc pen_process. I will do .-o to give it the same name. Then I'll just remove the -c. So press enter. Okay, we have little bit error. Okay, so %d instead of %s. So let us fix that. That is just a typing error, guys. So I'll just go .c. Just go and fix that error. So this is where we are making that error. So here should be %s. All right. So I save back and I clear the screen. I bring up to see what you previously typed. Just press Ctrl P like this to give you what you previously typed. So gcc pen.c -o pen process, and it compiles very well. Now LSC, we have our executable binary here. Okay, this is our executable binary. So when we run this code, we are going to see two processes running with the same name, pen_process. One will be the child, one will be the parent. The kernel will be the one assigning the process ID to each of them. Okay, the parent is going to be incremented by 1, while the parent will be the main process ID, then the child process will be incremented by 1. All right, so I'll do pen_process. I press enter and we'll wash. So we come to this next string. I will pass PSAUX space pipe to grep space. We do pen_process. Then we'll press enter. Now you can see two processes running. So the first process here is the parent, which has the PID 10246. You can see it here. Okay, the same name. Then the second process is this one that has 10247. Now let's check if it is the same thing here. You can see parent process running, child process running. So under parent process we have 10246 and child process running in the parent process ID. Child process jumping to get the parent process ID, we have 10247, but there is something not working here. The way it's been arranged is not proper, so let us fix that real quick. So we go back to the code. I believe that is because we have that slip there. I believe that is because of the sleep here is too much, so let us make it 3 seconds. So the sleep was the same number of that, so let's make this 3 seconds. Okay, so the loop there was too much, so the gap was too much, so we recompile again and we run again. So I will come here first so that it will not take much time. I bring up the previous code and I come here back and I put the name of the program. Okay, and I press enter. So wait for it, and I come back to this and I press enter. You can see the two process is running. Okay, we see child process running. This is the child process. Child process now run first. Child process ID 10358. You can see it here. Child process here is 10358. You can see it here. Okay, now parent process running. Parent process ID 10357. You can see the first one. You can see it 10357, but both of them have similar name. You can see pen_process and pen_process. So this is what we'll talk about. This is what process is all about. All right, child process comes first because we use the wait system call. Okay, when the child process is done, it gives control back to the parent process before the program now terminates. Okay, so isn't this very, very fun and very, very okay? Yeah, I think so. It's very, very nice. So if you like what I'm doing, please encourage me by sharing the video and hitting the like button. Share your comments, okay, if you want me to do more videos like this. Things like properties of the object of C language. Okay, we dive into explaining each of the keywords, what they are, and all the system calls. If you like stuff like this, just put it on the comment section. I will not hesitate to do videos like this. So see you guys on my next video and have a nice day. Be blessed. Bye.